For implicit differentiation, so in this slide, you can see what is an implicit function and also the same time what is an explicit function. If you remember the functions that we discussed before, so for example, y equals to x squared plus 5x minus 1, or the f of x equals, um, let's just say, 9x minus 3. So those examples of functions that we had are examples of explicit functions. And from the start of our discussion in differential calculus, from the very start, okay, so we actually differentiated explicit functions. So just like this one. So explicit function y equals to x squared minus 4x plus 2. So you already know how you are going to differentiate this, okay? So you differentiate the left side, which will become y prime, and then the right side, so differentiating it by power rule for the x squared, so we do have 2x minus, then 4x by constant multiple, the answer will be 4. And then the plus 2, the derivative of this constant is 0. So you already know it. How about if the function is like this? Okay? So if you see that the x and y are on the same side, whether on the left side or on the right side, as long as both are well together, okay, on a particular side or even both, okay, it is possible. So that function is the what we call as implicit function. And how are we going to get the derivative of an implicit function? So we actually do have here the steps. So the first thing that you need to do, if the function is implicit and you are going to differentiate it, is that you need to differentiate both sides with respect to x. So if say, just like what you were doing even before, um by applying the rules, okay, for each term. So if you see a term, okay, whether on the left or on the right or both, if you see a term, for example, we do have 12x squared, okay? So when we say differentiate each term on both sides with respect to x, you're just gonna do the same as what we did before, okay? Once you see that the term has x variable, you're gonna do the same as before. Or if you see a constant, of course, you're just gonna write 0 as the derivative. So if you see a term like this, so if we do have a term, okay, like this, so you apply the power rule here, isn't it? So we do have 12. Then we do have the power of 2. So let us write here the 2. So we're gonna multiply it, copy the base, that is x, and then the power 2, and then deduct 1. This is what we do. So let us simplify our answer. So it will become what? 12 times 2, it is 24. Then x raised to 2 minus 1, so simply x. So this is the derivative if we see 12x squared on either sides, or even, if we have a term with x variable. So we're just going to apply the rules. Next, as what you can see in the implicit differentiation a while ago, okay, the example. So again, it is possible that on one side, okay, we do have here the left and the right. It is possible that on one side, you can see x and y together. Okay, so we have a term with the x, we do have a term with a y, and then possible on the right side, we can also have the same. So what are you gonna do if you see a term, okay, with y variable? So if you see a term with y variable, say let's just say y cube, okay, then we do have the coefficient of say 4. Okay, so this term 4y cube is in the implicit function which we need to differentiate. So this is only an example. So what are you going to do if you are going to differentiate it in terms of x? As what you can see, there's no x here. Okay, if there is no x here, so the differentiation rule, so with a constant multiple, we're just going to apply here the general power rule. Okay, we're gonna apply the general power rule. If ever you see that you have y, okay, to be differentiated in terms of x. Or in other words, if you see a variable which will be differentiated in a different variable. Okay, so by general power rule, so what we're gonna do here, so let us copy the coefficient, okay? Then general power rule, copy the power 3 of y cube, copy the base y cube, deduct 1, okay? And then remember, in the general power rule, what we do is that we differentiate the base. So we need to multiply it by the derivative of the base. And what is the base of y cube? It is y. Okay. Then you just simplify this. So we have 4 times 3. So that is 12. Y. Power 3 minus 1, it will be squared. Okay. Then derivative of y with respect to x. Okay, so remember that the dy over dx, this is also equal to y prime. So simply you can just write that portion as y prime. Okay, it is prime. That's it. So this is the derivative of the term for y cube. Okay, so it is like a usual power rule. So you multiply 4 to the power of 3, so you do have 12. You deduct 1 from the power, so it will become y squared. The only thing that you need to write in addition is the y prime, which is derivative of the base y. Okay. So going back to the step, so after differentiating both sides with respect to x, the second one is you need to isolate all dy over dx or derivative of y with respect to x. Or you're gonna isolate all y primes, okay? All terms with y primes on the left side. And then if it is possible to factor out, okay, in which the common factor will be y prime, and then you apply dividing both sides. So you really need to, because your aim is to come up with only one y prime at the end. Okay, that is your goal. So let us have examples. So for example, we do have x cubed plus y cubed equals to 3xy. So how are we going to solve this? Or how are we going to differentiate, okay, or get the derivative? Please, before you get the derivative of a given, try to look at the terms first, okay? If you see that the x and y are on the same side, so just like this, we do have here the left and we do have here the right. So what you're gonna do is the implicit differentiation. And remember that, remember what are you going to do if you're going to differentiate a function with y? Okay, same as, with what I discussed in the previous slide. Okay, so let us differentiate this. So again, in the steps, we need to differentiate both sides with respect to x. So with respect to x, so let us just write it. So we have derivative of x cubed with respect to x, derivative of y cubed with respect to x. Then we do have here 3xy. This can also be written as 3 derivative of xy with respect to x. The xy here, okay, as what you can see, this is product because the two are multiplied, okay, to each other. Next. So let us differentiate. Since we already have the equal sign here, so we can remove this. Okay. Because this is already a function. Okay, so derivative of x cubed. So you apply the power rule. So we have here 3, which is the power. We copy the base. So 3 minus 1, we do have what? We do have 2. So that is 3x squared plus. Okay, here we do have the we need to get the derivative of a term with y. So we're gonna do what we did in the previous slide. So applying the general power rule, so you copy the power 3, copy the base, and then 3 minus 1 for the power, we do have 2. And again, you need to multiply it by the derivative of the base, which is y, because by general power rule, equals. So on the right side, as what you can see, we do have a coefficient of 3 to be multiplied to the product of x and y, which we need to get also the derivative. So if you still remember the product rule, okay, so we need to what? So we need to copy the first. So we do have here the first, and then y is the second. Okay, so y is the second. So first, that is x. Okay, then we're gonna multiply it by the derivative of the second. So second is y. Then since it is product rule, so the operation is addition. Then we're gonna copy the first. Okay. Then multiply it by the derivative of the what? So that is first derivative of the second. We're gonna copy the second. Okay, second y. Then multiply it by the derivative of the first. Like this. Okay, and then you close it. Okay, next. So let us rewrite the first term. We do have 3x squared plus, this will be 3y squared. Dy over dx, or derivative of y with respect to x, is what? It is y prime. So it is y prime equals, so we do have here 3 times, we have x, dy over dx, again, it is y prime, then plus y, derivative of x, so it is 1. Okay, derivative of identity. So this is 3x squared plus 3y squared y prime equals to, so we can already distribute, equals to 3x y prime plus 3y. Okay? We are not yet done. So the next thing that we need to do is we need to isolate all terms with y prime on the left side. So I'll erase this portion. I will erase this portion. Okay. So that is again 3x squared plus 3y squared y prime equals 3xy prime plus 3y. I'll just remove this. So we need to isolate. Okay, when we say isolate terms with y prime, so since you can see here we do have addition, so what can be applied here is transposing. Okay, or moving a term to the other side. If it is positive, then it will become negative, vice versa. So we have on the left side the 3y squared y prime. Okay, so we have this with the y primes. So we're gonna write it together. So this 3xy prime, it will be transposed to the other side. So it will become negative 3xy prime. Okay. Then on the right side, we have 3y. So on the left, we have 3x squared. So we're just gonna transpose it. So that is negative 3x squared. Okay. The next thing that you need to do is you need to factor. Okay. You need to factor the y prime so that you can come up with with one y prime only. So by factoring, we have y prime. Quantity, we do have 3y squared minus, on the second term, we do have 3x, okay, equals 3y minus 3x squared. Next. So what you can do here, you can actually divide both sides by 3y squared minus 3x because you need to isolate y prime on one side only. So in order to isolate it, we're going to divide both sides by this 3y squared minus 3x. Then after that, we can already cancel. Okay, so as what you can see, we do have y prime equals to 3y minus 3x squared over 3y squared minus 3x. Okay, but then this is not yet the final answer because as what you can see on the right side, we do have 3, okay? 3 on all terms. So possible we can cancel the 3. But before you cancel the 3, please make sure that you factor first. So we have y prime equals. So let us factor the right side. Okay. So the numerator, so if we factor out the 3, so we're gonna have y minus that is x squared. So y minus x squared. Then on the denominator, what we're gonna have is the y squared minus x. Okay? So we factor first before cancellation will be done. Remember that. You don't cancel here right away. It is not allowed. Cancellation only once you're done factoring. So what we have is y prime equals to y minus x squared over y squared minus x. And this will be the final answer. Okay? So I will be clearing the screen. Let us have the next. So we have x squared plus y squared equals to 19. Again, you try to look at the given function, and as you can see, the x and y are on the same side. So what we're going to do here is implicit differentiation. So get the derivative of all the terms. So we do have derivative of x squared with respect to x, derivative of y squared with respect to x, and derivative of 19 with respect to x. So derivative of x squared, so that is by power rule. So we do have the power of 2, copy the base x, then power 2 minus 1, so it is only 1, plus y squared, apply the general power rule here. So we do have here the power of 2, copy the base y, then the power 2 minus 1, so it is only 1. And then do not forget that it should be what? By general power rule, we need to multiply it by the derivative of the base y. Then equals derivative of 19, so we have 0. Okay. I'll just rewrite it in a way that the equal signs are aligned. So on the right side, we do have 0. Then we do have here 2x plus 2y times derivative of y. Like that. The equal signs should be aligned. Okay. Then continuing, so we do have 2x plus 2y. dy over dx, that is y prime, equals to 0. So the next is you need to isolate the term with y prime on one side only. So the next thing that you are going to do, so isolating, so we'll just leave the 2y, y prime on the left. Then the 2x, you have to transpose it to the other side, so that will become negative 2x plus 0. So negative 2x only. And then you need to divide both sides by what? The 2y, because we only need y prime here. So dividing both sides by 2y, so we can cancel the 2y. So what we're gonna have is the y prime equals to negative 2x over 2y. That's it. Actually, as you can see, we can cancel the 2. So here, no need to factor because we only have single term for, single term in the numerator and denominator. So automatically, it is allowed to cancel. Okay? Because there's no addition, no subtraction, so we can cancel already. So the answer here is y prime equals negative x over y. The negative can be put on x. It can be put before the bar. Okay? It is just the same. So this is the answer for number 2. Okay? Next. So let us have the third. I will be clearing the screen. So again, if you try to check, we do have x and y on both sides. So we're going to apply here implicit. So we do have here number 3. So y minus x minus 3. So y minus the square of the difference of x and 3 equals to 4. So we need to differentiate again each term that we can see. So derivative of y minus derivative of x minus 3 raised to 2 equals to derivative of 4. Okay? So derivative of y with respect to x, it is what? It is y prime. Then minus that is x minus 3 raised to 2. So what we're going to apply here is the general power rule. So by general power rule, you copy the square, the power, copy the base x minus 3. Okay, then power is 2 minus 1. Then multiply by the derivative of the base x minus 3. Okay. On the right side, derivative of 4, the answer here is what? The answer is 0. So the answer there is 0. Okay. Then these two are what? These two terms that you can see here separated by, well, we do have here multiplication. So this is only, well, this is a group because it is from the derivative of this exponent x minus 3 raised to 2. Then copy the y prime minus 2 times x minus 3. 2 minus 1 is 1. Then derivative of x is 1. Derivative of negative 3 is 0. Then that is equal to 0 for the derivative of 4. Continuing, we have y prime minus, so 2 times x minus 3. We do have here 1 minus 0 is 1 equals to 0. So y prime minus 2 times x minus 3 equals to 0. And the next thing that you need to do is you need to isolate y prime on one side only. So we have y prime equals, so negative 2x minus 3, you transpose it to the other side. It will become positive 2x minus 3. Okay? Actually, this can be your answer. Or if you would like to distribute, okay, so we have y prime equals to 2 times x, so we have 2x, 2 times negative 3, so we do have negative 6. So you can have either of these answers. Okay. So let us have the last, number 4. Again, looking at the given, the x and y are on the same side. If you look at number 1, x and y are on the same side on both sides. So implicit differentiation. Okay. So I will clear the screen. Let us just switch to the black screen. Okay. So the given in number 4 is x squared minus 3y squared minus 10x minus 16y equals to negative 89. Okay? So again, we're gonna differentiate each term, okay, on both sides with respect to x. So that is derivative of x squared with respect to x minus 3. So we do have here the coefficient of 3. So we're just going to copy it and then multiply by the derivative of y squared with respect to x minus derivative of 10x minus derivative of what? 16y. If you would like to write the coefficient 16, okay, before the derivative of y, you can do it. So we do have 16 times derivative of y, okay, equals, so derivative of negative 89. I'll just move the equals negative 89 here so that the equal signs will be aligned. Okay. Next. So derivative of x squared, so by power rule, so we do have power of 2, then base of x, 2 minus 1, so the power will be 1 minus 3. Okay, so 3 derivative of y squared. So this is power of 2, copy the base y, 2 minus 1. So we do have the power of 1 here. If you still want to write, you can. Actually, you can already directly put the derivative here. So we know that we need to multiply it by the derivative of y. Okay? You can actually write it automatically. Okay? So if you see or if you need to differentiate the y, just apply power rule. So you do have 2y and then you just include y prime. That's what you can do to make it a little short. Okay. So like a power rule, so 2y and then just include y prime. Next, minus 10x. This is by constant multiple. So derivative of 10x is 10 minus, so we do have here 16. Derivative of y with respect to x is y prime equals derivative of negative 89 is 0 because it is constant. And then again, we need to isolate the terms with y prime on one side only. Okay, so in isolating, so let us just copy it. So we do have negative. So this is what? 3 times 2 is 6 y prime minus 16 y prime equals. So on the left, we can transpose 2x, so it will become negative 2x. The negative 10 will become positive 10. Um, we can actually factor this negatives, okay, here, so that our so that the left side will become positive. Or if you like, you can switch the left and the right. That's what you can do. So if we're gonna switch, so the y the terms with y prime here, okay, the left side will become all positive. Okay, here. If we're gonna switch. So what you can do, you can just what? You can just factor if you like. So let us factor. So we have 6y prime minus so that will become 16 plus, okay, that is plus 16 y prime. That's what you can do. The negative 2x plus 10. Then divide both sides by negative 1. Okay. So we can cancel this. So what we have here is 6y prime plus 16y prime. So we have the prime here equals, okay. So here what you can again do is before you cancel the negative one, so you need to factor. So we have negative 2x, okay. Then since this is positive, so automatic, what will be inside the parenthesis will also be what? It will become minus or negative. Then 10, negative 1 here. Then you cancel, okay. Again, the shortcut that you can do here, you just switch from here. Okay, you just switch the two sides. Okay, you transpose. So that no need to do this cancellation because it's very long. So what we have here is 2x minus 10. Okay, on the right side. Then on the left side, we do have 6y prime plus 16y prime. Okay, next. So I will be erasing the upper portion. Okay. So the given is y squared. Okay, so let us write this. That is 6y prime plus 16y prime equals 2x minus 10. Okay. So again, you need to what? You need to factor or come up with one y prime only. So what you can do is what? So put it before. So you factor it out. So what will be in the parentheses? We do have 6y and then 16. Okay. Then on the right side, you just copy. So we do have 2x minus 10. Then we can what? We can divide both sides by 6y plus 16. Then we can already cancel. So what we're going to have is y prime equals to 2x minus 10 over 6y plus 16. As what you can see on the right side, it can still be simplified since all the terms are what? Divisible by 2. Okay? So we have y prime equals, so let us factor. So 2 and 2. So on the numerator, we do have x minus 5. On the denominator, we do have 3y plus 8. Okay. Next, we can already cancel the 2 because it is common. So the answer here is y prime equals to x minus 5 over 3y plus 8. So this is the final answer for this implicit differentiation of the given function. Okay.